guys, Chris here with Stoked About Science. A little bit more with pressure for you. So I've got here a bell jar, this glass jar, kind of looks like a bell, and then I have a vacuum pump here which is going to suck all the air out from inside this jar. And I'm going to take this balloon and put it here inside this. And before we actually do this, I want you to make a prediction. So pause the video after I'm done here and make a prediction before you see it. When I turn the pump on, is the balloon going to get bigger, smaller, or will it stay the same? So pause the video and make your prediction. Okay, so let's give it a shot now. Pump on, it's going to suck the air out. Watch what happens to the balloon. You can see it there starting to change some. I've got this strawberry basket in the bottom just so it doesn't get sucked down to the hole and plug it up. That's the only reason that's there. So you can see it's definitely getting bigger. Well, the question maybe is, why is it getting bigger? Okay, we'll stop it there. Well, this balloon has air inside it, and that air is causing pressure, and that pressure is pushing out. That's all the green arrows. But we have air pressure all around us, and it's pushing back in equally. And so these arrows are all balanced. So it's like these guys are having a pushing war against each other, but they're exactly balanced, so the balloon stays the same size. That's how the balloon is normally. But when we take the balloon and put it in the vacuum chamber and suck the air out, now these little arrows pushing back in are really small. The air pressure inside this chamber is small. So the air inside the balloon, though, is still a bigger pressure. So in that tug-of-war, if this side is the balloon right here and this side is the air, it's a lot smaller, so the balloon wins, and it pushes that thing out and it expands bigger. So now if I let the air back in, so I'm just going to open the valve right here, you can see what happens. The balloon gets smaller because now air is back in there creating pressure, and it's pushing back in on the balloon. So the pressure equalizes and goes back to its normal shape. Okay, now I've got some shaving cream and I've got a jar here, and I take the shaving cream and put it into the jar. If I can get enough here. Come on now. There we go. Okay, and I'll put a lid on this. The lid has some holes in it that I punched. And now, put that guy back on there. Turn the pump on again. Now before I do, you should ask yourself, what's the shaving cream going to do? Is it like the balloon, or is it different enough from the balloon that it'll do something different? So we'll see here. Okay, that's all sealed up good and tight. I'm not seeing anything. Are you guys? But wait. Ah, the shaving cream does want to expand. There's pressure inside these little teeny air bubbles inside the shaving cream, and those want to expand when we lower the pressure in here, just like the balloon did. And so that makes this expand out through the holes, and it gets bigger and bigger and bigger. Okay, so that's probably pretty good. That's a full thing of shaving cream. But watch what happens now when I let it back in, because it's not like the balloon. Shaving cream's different. Now, number one, shaving cream makes a big mess. That's kind of fun. But if you look closely, we have shaving cream here, but it's just kind of goopy. There's not much air left in it. So the balloon doesn't let the air get outside of the balloon, but the shaving cream, the air can sneak out and be sucked out of the shaving cream, and so it goes out. And then when we let the air back into the container, the air doesn't go back into the shaving cream, so we have kind of like goopy, airless shaving cream is what's left. Okay, so here is your challenge, something to make at home. I've got here a Gatorade bottle. You can use Powerade or any kind of like stiff sides to the bottle, like an apple juice or something like that. And I took a little hole and drilled it in the bottom. You could like punch one in or cut one, but a drill is actually the easiest way. And then take a balloon and put it on the lip like this and push it down in there. I can create a little vacuum chamber in this, and I'll show you kind of how I do that. First, I'm going to blow air into it, like this, and then when I take my hand off, you can see down in there that it actually doesn't go down. Well, there's a bit of a trick to it. I've got my thumb over something here. Maybe you noticed that, right? Over the hole that I drilled. And when I take my thumb off, it lets it out. In fact, you can't even blow this up all the way unless you have a hole there, because there's nowhere for the air to get out that's in the bottom. As I blow in up here, air has to escape somewhere. So when I cover it then, as that balloon tries to go back up, now it creates low pressure in here, and it doesn't let it go back up again. It keeps it down in there because the pressure down here is greater. But it always looks awesome looking down into the throat of an open balloon like that that's, you know, not tight or anything. It's kind of cool. Here's sort of a close-up of it. Maybe you can see that a little bit better. Still got my finger on it. And when I tilt it like this, you can see that is an open throat there to that balloon, and it's kind of cool to look down into. Move my finger, and there it goes. So I guess the question is, can I inflate this without blowing into the top? Well, yeah, that's where the vacuum chamber idea comes in. If I suck air out here, I'll be just like a vacuum chamber. I'll be like the pump, and I can make the balloon inflate just like the vacuum chamber made the balloon inflate. And there you go. See if you can do that at home. And if you can, email me a video doing it, because I want to see if you can. Thanks for watching.